What I'm showing here on the screen is a demo that I've been working on for a bit that is intended to show a really awesome feature of Akka, which is the multi-region replication. And I wanted to show uh, how it does it in action. When I first learned about multi-region replication, I was blown away by, okay, wow, this is a really cool feature. But I was really curious about, well, okay, how fast does it do these things? How does it perform? What's the latency between replicating, things like that? And I like to do demos that are visual, so I came up with this idea for this demo where I've got this grid, and but right now what I'm showing is there's two web pages side by side, and each web page is pointing to a different region in this service, this Akka SDK service that I built that has been deployed to an Akka serverless platform with multi-region capabilities. And I can show you what regions that this is in. Let me zoom in at the top. The top of the screen shows like this one is in region AWS US East 2, and the other web page is pointing to AWS EU Central. So it's in Europe, and the the data that you'll see on the screen here in a moment, the data that you see in the screen on the left is coming from that region in the US East and Amazon. The data that you see in the screen on the right is coming from Europe, from databases in Europe. So the basic capability of this app is that each grid cell here, you can see when I mouse over, it's highlighting a cell. Each grid cell can have some state. The primary state is a color. So what I can do is I can change the state of the grid cell. So I can change the color to red of one cell, change another cell to orange, make this next one green, and this next one blue. But what you could see was, as I was making state changes to those grid cells on the left, the data changes that were being done there by my Akka service were being almost immediately replicated over to Europe. And the data you're looking at in Europe is coming from databases in Europe on the right side of the screen here. So, and the latency was, sub-second. So visually, it's like, okay, well, we can kind of measure seconds, but we can't really, as humans, measure sub-seconds. So what I added this capability to the app where it captured some timing data. So when I mouse over one of these grid cells, it pops up and shows this is other data that's being captured in this grid cells. These grid cells are represented by entities, and these are a really important feature of the Akka SDK. Entities are where data changes occur. Entities basically are, the unit of state is basically an object with attributes. That's pretty much it. But with behavior, and these are stateful things as well. They get pulled into memory, they stay in memory. This isn't a stateless system, it's a stateful system. In any case, the performance data I captured here is a little bit of a mechanism. I won't bore you with the details now. In other videos, I'll go into more detail about how this actually works when I should describe what is an entity and then use my demo code as an example of an entity with some interesting behaviors. But the timings are what's interesting. So you see there's entity to view 3 times, and that's because this service is running in 3 different regions. It's running in AWS US East 2. It's also running on GCP US East 1, so it's a Google Cloud Platform somewhere in the East Coast of the US. And then it's also running in EU Central. The times, though, you can see that what I mean by entity to view. Well, this is entities change their state. That state gets persisted, but there can be consumers of those state changes because this is an event source entity. It's emitting events. So the view is actually a consumer of the events from the entity. So the view runs independently of the entity. So there was 4 millisecond latency between the entity changing and the view updating itself with that change from the entity. In GCP, it was 26 milliseconds from the entity changing in US East 2 to it getting changed, the data getting replicated to GCP, and then the view in GCP, there's another view in GCP US East 1, 26 milliseconds. Even more spectacular, I think, is that the time that it took to replicate the data from the US to Europe, from entity in the US to view in Europe, was 60 milliseconds. So each one of these different entities has its own data that is captured about how long each one of these things took to do these different activities. Another thing you can do with this app is you can, I like to be able to generate a lot of activity. So I can say, I'm going to, let me just pull it down a little bit more. I'm going to change 200 cells. I'm going to make them orange. So it's going to submit requests to change 200 cells. So you can kind of see it roll down the page, both sides at pretty much the same rate. But again, the timing data is there as well. If I mouse over any one of these cells, it shows the performance data. And one more thing I can do with this is I can draw a circle. So I can say, like, create a green circle with a radius of 14. And, so it's generated some load just to, want to see some, how do things behave doing, like, real activity, or at least a quick simulation, a burst of activity, and get the timing information as well. So like this one, while I just moused over one of the cells, and it took 73 milliseconds to replicate across machines. I did another video on this where I introduced this app in more detail, but I don't want that, so check that out. I got a link. I have a link to that video in the description of this video. But really, I want to show you something else here. So I have another part of this demo. And this part is a simulation of what's going on kind of behind the scenes, behind the curtain, below the abstraction layer of Akka. And it's kind of sad because there's some really spectacular things going on in Akka, but we don't have to really care about it. It's like, we have a car or a cell phone. There's, like a cell phone has unbelievable technology in it. And we don't care. We're just banging on the glass to do whatever we do with phones. Cars, the same thing. There's, cars they're like rolling data centers, they call them these days. Spectacular technology, but hey, we're just steering and driving. We don't care. It's kind of the same thing here. We all we care about with Akka, all we have to care about with is like the business functionality that we want to implement in the service. But there's this spectacular technology that's going on below. And I wanted to kind of try and attempt to show you that. And that's what I'm going to do here. So this is a kind of a 3D visualization of what's happening in a multi-region environment at a more detailed level. So in this simulation, I'm going to redo it because I want to see if I get a better orientation. That one's not good either. No, it's not cooperating with me. I'm going to have to fly into it. Anyways, you can fly around this, and it uses a force separation of like force fields to separate common thing in 3D or these kinds of graphs. Okay, that's pretty good. So while it's settling down, the central sphere here represents the service. If I click on it, it's called the Akka system. It says there's 3 regions, and these 3 regions are handling around 10,000 entities. Again, everything here is simulated. This is not a real Akka application. It's a simulation. Now, the blue spheres represent regions. So there's 3 regions, there's 3 blue spheres. And if I click on one, it says, the first one says it's a EU Central 1, the second one is US West 1, and the third one is US East 1. So again, I'm just, again, it's a simulation, but we're just showing, that there's 3 regions here. Now the green spheres are nodes in an Akka cluster. So what's happening is that every region that you deploy a service to, every region gets its own Akka cluster. So right now there's only 1 node in the Akka cluster. Akka clusters can have multiple nodes. So this one has 1 node. And then the amber spheres here are called shards. And shards are a really innovative way that the Akka team came up with for distributing workload across a scalable environment. So that's what I want to show here. So in this simulation, I can simulate a kind of an increase in load. And I've just increased the load a little bit. This is not quite how it actually works for real, but real enough that it's a close approximation to what happens for real in a real Akka cluster. Here, what I really just wanted to trigger was adding another node to the cluster. So before, when we had one node, there were 100 shards allocated to that one node. But now if I click on these nodes, you can see that one node has 50 shards and the other node has 50 shards. So the number of shards per cluster stays fixed. That's a configuration setting for the cluster. So the cluster scales up or scales down. The number of shards doesn't change, but where these shards are distributed to, which nodes that the shards are distributed to, does change. That's dynamic, and that's the kind of the genius of what's happening in Akka to distribute workload. And you can also see that, you know, I kind of increased the load to 20,000 entities because each shard is responsible for a subgroup of entities. And cumulatively, all the shards now are handling more entities, but those entities are being driven to other nodes because their associated shards have been distributed to other nodes. So you can see one shard now has 50 shards. I'm sorry, one node has 50 shards, and the other node has 50 shards. Same thing in all these clusters. You know, they all scaled up. Now, so this continues. I can add, say, a bit more, and now we have 4 nodes in the cluster. And if I click on these nodes, now the number of shards is 25, but it's around almost 10,000 entities, 25 shards, 9,500 entities, 25. You know, so what's happening is that the rules for scaling up are a little bit different in my simulation versus how it actually happens in Akka. I'll explain that in a few minutes. In a real platform, but the idea is the same in that each node, we don't want to overwhelm it with traffic. So the way it actually works for real in Akka is that Akka is normally running on an orchestration layer like Kubernetes. Kubernetes is managing the containers. Akka is managing what's happening inside those containers. So Kubernetes is the one that recognizes that, say, the containers that are currently running for a given cluster are getting hot. You know, the CPU utilization is going up, or the memory utilization is going up. There's thresholds that are set in Kubernetes that if those thresholds are passed, Kubernetes will be triggered to say, well, okay, this application is starting to get busy. I need to give it some more processing capacity. So Kubernetes goes, hey, okay, I'm going to fire up another pod, which starts up another container, which starts up another JVM, and the Akka is running in the JVM, and Akka starts up and it goes, hey, I need to see if I'm part of a cluster, and it starts talking in a network. They find each other, they start talking, and the cluster decides how to divvy up the shards so that the load gets redistributed. That's it. That's pretty cool. All this happens with some really interesting dynamics that are built into Akka. It's not like a shock thing. You know, there's kind of a slow, or not real slow, but like over a period of seconds, workload kind of is redistributed, rebalanced across the nodes. And the rebalancing is happening at the shard level. The Akka system as a whole, the cluster, is deciding how to rebalance, what shards go where on each node in the cluster under its current configuration. And when you scale down, because say the workload goes down, Kubernetes may decide that it's going to scale down, and because of it doesn't need all those pods, so Kubernetes will do like an orderly shutdown of a pod, and Akka just reacts to, okay, we lost a node in the cluster, and it's going to, again, it's going to redistribute the shards, and their associated entity will be redistributed to the remaining nodes in the cluster. And because you can handle scaling up and scaling down with in an orderly fashion, you also, in a way, solve the problem of what do you do when a node fails unexpectedly. So I'm going to simulate that. So right now, we have 33 shards, 34 shards, 33 shards. But I'm going to simulate a failure. So I'm going to control click one of these nodes. So now it went back to 51 shards and 49 shards. So right now these two nodes that are remaining assume that workload. But this is the beauty of the relationship between the orchestration layer, like Kubernetes, managing the containers, and Akka managing what's running inside the containers. So Kubernetes recognized that, hey, this cluster, this unit of execution lost a pod. It wants 3 pods right now, but it for some reason it just dropped down to 2, but it really needs 3. So Kubernetes recognizes that, and this happens pretty quickly, usually in a number of seconds. Kubernetes will fire up a pod, the pod will start up, Akka starts up, and then that new third node in this case rejoins the cluster. So that's how it handles. Almost in a way, Akka kind of shrugs off of the failure of a node because it was built to handle this kind of the dynamics and the rigors of running in a fully distributed environment. Now, another feature of this demo is that if I click on one of the shards, you can see that the entities for that shard kind of explode out like a starburst. But not only did it expand in one region, but remember the data is replicated between these regions. So when I expanded a shard in one region, its clone and all the cloned entities associated with it expanded in the other regions. So this is kind of what's happening in Akka is that because the data is replicated in a multi-region environment, these different entities in one region have their clones in other regions. And just to kind of cement the point home, if I click one of these entities, and you can see at the top, these entities have a unique ID, like this is A2NOO, but it turns red, but it also there's a red line connecting all 3 of them. But you can see that I make a connection between the clone of this entity, the specific entity, and its specific shard in the 3 different regions. And a cool little feature of this demo is that I can just to prove that entity is there, I can fly into it. You can see there's the red entity, and I can follow the line back to another node, and we can fly to it. So there's the third one. It's kind of fun. It's a fun capability that came with having this 3D visualization for this demo. So that's pretty much how things work here. Is that you got this this capability where you have multiple regions. Each region has its own Akka cluster that can scale up, that can scale down, it can handle failures, recover failures because of its relationship between the orchestration layer like Kubernetes. And then you have things down to this from kind of the region to node to shard to entity hierarchy that's going on with all the replication that's going on. So for when I changed the color of one of those cells in the grid on the other demo to red, that change happened, say, here, and then it emitted an event that got quickly transmitted and replicated to its counterpart entity, its cloned entity in the other 2 regions. And then that cloned entity emitted an event in its own region, which then triggered an update to a view in its own region. So there's a view in this region, there's another view in this region, another view in this region. And those 2 screens that I was showing, those 2 UIs for the different regions, we're looking at the data from those individual regions, actually through the views. I hope I didn't go too fast with that. A lot of concepts going on here right now, but that's what's going on. Anyways, this demo is it's a single page web page type of demo. It's mostly couple thousand lines of JavaScript, but you can look at the source code. It's part of the project that the service comes with. So the GitHub repo for all this code, both demos, is in one GitHub repo, and it's the link for the GitHub repo is in the description for this video. This demo has a help file, so it has help that describes how it works. And if we go back to the other, the real service here, the real application, this also has a even more extensive help file that explains how this, the real demo works, and the controls you can do to manipulate it, and some of the workings that are going on with it as well. All available to the GitHub repo. I hope this made some sense. I hope it gave you an appreciation for some of the really spectacular things that Akka does. Please like and subscribe. Keep learning, and I hope to see you in other videos.